Planetary systems outside our own are like distant cities, whose lights we can see twinkling, but whose streets we can't walk. By studying those twinkling lights, though, we can learn about how stars and planets interact to form their own ecosystem and make habitats that are amenable to life. In this image of the Tokyo skyline, I've hidden data from the newest planet-hunting space telescope on the block, the Kepler mission. You see it? There you go. This is just a tiny part of the sky that Kepler stares at, where it searches for planets by measuring the light from over 150,000 stars all at once, every half hour, and very precisely. And what we're looking for is the tiny dimming of light that is caused by a planet passing in front of one of these stars and blocking some of that starlight from getting to us. In just over 2 years of operations, we found over 1,200 potential new planetary systems around other stars. To give you some perspective, in the previous 2 decades of searching, we had only known about 400 prior to Kepler. When we see these little dips in the light, we can determine a number of things. For one thing, we can determine that there's a planet there, but also how big that planet is and how far it is away from its parent star. That distance is really important because it tells us how much light the planet receives overall. And that distance and knowing that amount of light is important because it's a little like you or I sitting around a campfire. You want to be close enough to the campfire so that you're warm, but not so close that you're too toasty and you get burnt. However, there's more to know about your parent star than just how much light you receive overall, and I'll tell you why. This is our star. This is our sun. It's shown here in visible light. That's the light that you can see with your own human eyes. You'll notice that it looks pretty much like the iconic yellow ball, that sun that we all draw when we're children. But you'll notice something else, and that's that the face of the sun has freckles. These freckles are called sunspots, and they are just one of the manifestations of the sun's magnetic field. They also cause the light from the star to vary, and we can measure this very, very precisely with Kepler and trace their effects. However, these are just the tip of the iceberg. If we had UV eyes or X-ray eyes, we would really see the dynamic and dramatic effects of our sun's magnetic activity, the kind of thing that happens on other stars as well. Just think, even when it's cloudy outside, these kind of events are happening in the sky above you all the time. So when we want to learn whether a planet is habitable, whether it might be amenable to life, we want to know not only how much total light it receives and how warm it is, but we want to know about its space weather, this high-energy radiation, the UV and the X-rays that are created by its star and that bathe it in this bath of high-energy radiation. And so, we can't really look at planets around other stars in the same kind of detail that we can look at planets in our own solar system. I'm showing here Venus, Earth, and Mars, 3 planets in our own solar system that are roughly the same size, but only one of which is really a good place to live. But what we can do in the meantime is measure the light from our stars and learn about this relationship between the planets and their parent stars to suss out clues about which planets might be good places to look for life in the universe. Kepler won't find a planet around every single star it looks at, but really, every measurement it makes is precious because it's teaching us about the relationship between stars and planets and how it's really the starlight that sets the stage for the formation of life in the universe. While it's Kepler, this telescope, the instrument that stares, it's we, life, who are searching. Thank you.